I think. I've seen these pages repeatedly over the last week, but this is the second page.
Okay. And then did you get my emails by chance? I sent them at 4:20 about.
There's my emails right there.
That's so weird. I don't get that.
I got a feeling you're misspelling it.
Maybe. Yeah.
In other words, you could be doing a couple of things.
Mhm. Let me type it in because that's really weird.
AN. A lot of people will put EN. And then it's 1949. That's not an L. That's a 1949.
Is it capitalized or no?
Doesn't matter.
Okay.
I would not capitalize it. But
Cowan 1949
at gmail.com.
gmail.com. So weird.
It is kind of weird. But frequently, it's a simple one character is, or there's a space where there shouldn't be, or something.
1949, yeah.
Send me an email without any attachments. That's the easiest one that's going to go through. And then that will guarantee that you're typing it in properly.
Okay, sure.
Okay? And
okay.
then we'll just wait and see if that comes through.
Okay.
As far as tonight goes, I think this material is what you're working on, is it not? You're still on quadrilaterals?
We are, yeah.
Okay. Well, let's go through some of these. We went through the first page in one of our previous sessions. You remember these? I think we did most of these.
We did, yeah.
Okay, well, let's pick up with this one.
Okay, and then we have a quiz tomorrow.
Okay.
So he gave out like a review packet for us.
Okay.
To just go through it.
That's different than this. Tell me if this is part of the review packet. This looks like exercises from the book only.
Yeah, it's not on the review sheet.
Okay, this is my fourth page that I have.
Okay.
Okay, I'm sure that this will be helpful, us covering these 4 pages, but not as good as if you sent me.
Yeah.
No email yet.
Did it work? No. Like, did you get, like, no email?
No email.
Huh.
That top row, if there was an email. Now, maybe your phone needs some sort of a message or something in the subject field or something. It may
maybe
send an empty email, but
yeah, maybe my mom changed her password for her emails, so maybe I need to like refresh that.
I don't know. I am honestly at a complete loss as to why this isn't getting to me.
Me too, yeah.
Yeah.
So weird.
Without an attachment.
Yeah, it's just a simple hey and like nothing.
Exactly.
Yeah.
So I'm not sure what we're going to do about that. We'll give it a minute to see if it comes in. But in the meantime, let's do these. It's probably not as good as your review material, but if your quiz is on quads, then this will be fine. This will be perfect for you.
Okay. Yeah.
First of all, we have to classify what kind of a quadrilateral it is, and then they want us to solve for the variables, x and y.
Okay.
So that first one, 26. What kind of a quadrilateral is
that? That's a rhombus.
Good.
Parallelogram.
Rhombus.
Rhombus, yeah.
Specific. Because parallelogram doesn't have to have 4 equal sides.
No.
Whereas rhombuses do. That's the main definition of rhombus, is 4 equal sides. It turns out that all rhombuses are also parallelograms.
Okay.
Okay, and they have the same rules that parallelograms have.
Mm-hmm.
Which is what? Parallelograms or rhombuses have opposite angles.
That are congruent to each other.
Okay, so that's congruent to that.
Uh-huh.
That's congruent to this. And what
Yep.
about adjacent angles?
Adjacent angles. Ooh, I remember this.
Think acute and obtuse. What do those have to add to? What's the magic? Yeah, the magic number in geometry is 180.
Okay, yeah.
So adjacent angles are supplementary. Those two are supplementary, those two are supplementary, those two are supplementary, and those two are supplementary.
Okay.
Okay? That being the case, what is x?
If that's the case, then x would be, so it's 104. How would you do this? So you would do 180 minus 104 divided by...
That's it.
Yeah, just 180 divided by 104. Or minus.
Minus 104. In other words, supplementary means they add to 180.
Okay.
What you're repeatedly doing in geometry is subtracting numbers from 180. It just turns out that, you know, if I give you a triangle and I tell you this is 60 degrees and that's 70 degrees, you have to add those two together and subtract from 180 to get 8.
Exactly.
Or 50.
Exactly.
Excuse me. Okay?
You're good.
So the secret in geometry is to be able to subtract from 180 because you're doing it so frequently.
Okay.
So what is x?
X would be 76.
Okay. And how do I solve for y? What equation can I write that will allow me to solve for y?
Y plus 8 plus 3y equals 180.
No. It's only equals. This is a measurement.
Equal.
That's a measurement of the side length.
Okay. So just be equal to 3y.
Right.
Okay.
With that hash mark, we know those two side lengths are equal.
Okay.
In all of these problems, they will use degrees if it's an angle. They'll use this degree designation. Notice in 28, it's hard to tell what they're talking about when they say 5x, but the degree means they're talking about that angle. Okay. And then when they say 2y, are they talking about the angle or are they talking about the segment length? It must be the segment length because there's no degree marker on it.
Okay. Makes sense, yeah.
Alright, so solve this equation.
So you subtract y, we can subtract y from both sides, and so it'd be 8 is equal to 2y. And then y would equal 4.
Okay.
Cool.
And this is what typical geometry really is that it turns into algebra. Almost all of it. What kind of figure, what figure is that? What quadrant?
Is that a square or rectangle? It looks, yeah, it's a rectangle. It's kind of hard to see from here.
Well, you actually bring up a good point. We don't know. In other words, it doesn't look like a square.
No.
They didn't say anything. If it was a square, they probably would have said this side's equal to that side's equal to that side's equal to that side.
Exactly, but they didn't.
But it's a rectangle, and they still didn't tell us that this side is equal to this side. So, it's a rectangle, okay?
Okay.
And that's all we need to know. Even if it's a square, we're going to be able to solve for x and y by assuming it's a rectangle.
Okay.
Because squares are rectangles, believe it or not. The square is just a special kind of rectangle.
Exactly.
Like a square is a special kind of rhombus. Rhombus that has 90-degree angles. So, give me some equations that will allow me to solve for x.
We could do, well, we know that a quadrilateral adds up to 360 degrees.
Rectangle,
my bad, yeah.
And so we're not trying to solve for any angles.
No.
We're trying to solve for side lengths. So what are the properties of the side lengths of a rectangle?
Well, they all are 90 degrees.
That's angles again.
So sides.
If I draw a rectangle, what do I know about x and
And,
this side up here and y and this side over here?
we know that y would be equal to y and then x would be equal to x.
In other words, opposite sides are equal.
Okay, yeah.
Okay?
So,
In a rectangle,
oh yes.
opposite sides are equal. So what equation can I write?
X plus 31 is equal to 5x minus 9.
Solve that.
And then we could subtract x from both sides.
So just read the second line to me.
Yeah, so 31 is equal to 4x minus 1 or minus 9.
Now the next line.
Then you would add 9 to both sides. So it'd be 4x is equal to 40, x would be equal to 10.
Okay. And an equation to solve for y.
We would do 2y plus 35 is equal to 4y plus 5.
Solve that.
And then you would subtract 2.
This time do both steps at once. In other words,
Okay.
gather all your variables on one side, gather all your numbers on another, do it in one step.
Okay. So it would be 2y, or 35 is equal to 2y plus 5.
No, do it everything in one step.
Oh, okay, I got you. 2y is equal to 30.
That's what I meant.
Okay.
In other words, subtract the number and subtract the variable at the same time.
Okay. And then y would be equal to 15.
Okay.
Cool.
28, what kind of figure is that?
That's a square. Okay, and then we would...
Because why?
Because the all four sides are congruent to each other, like the opposite sides are congruent
We
to
don't
each
know
other.
that. They don't have any hash marks.
No,
They don't tell us that the four sides are equal.
Okay.
We know it's either a square or a rectangle because it has four 90-degree angles.
Okay.
But
yeah.
there's one thing that makes this a square and not just a rectangle. It's the fact that the diagonals form a right angle.
Okay.
Okay? In other words, if I had a rectangle, and if you're trying to prove this to yourself, always elongate it.
Uh-huh.
Now when I draw the diagonals, you can see that they are not perpendicular to one another.
No.
That's not a right angle.
No,
Okay?
not at all.
Were, that would be a square. It has to be or a rhombus, really. It's the rhombus whose diagonals always form a right angle.
Okay.
Okay? Yeah. So the fact that this is a right angle means that is equal to that's equal to that.
Okay. Yeah.
Okay? Now, now that I know it's a square, what is 5x equal to?
90 degrees.
Hold on. 5x refers to this tiny angle right here, not the whole cube.
Okay.
5x refers just to that half of that angle.
Okay.
So what is that angle? When you take a square and you draw diagonals, what's this angle right here?
So just be half.
Yeah, it bisects the 90-degree angle. So that's always a 45-degree angle.
Okay, that makes sense, yeah.
So 5x is equal to 45.
Yep. And then x would equal to 9.
Okay, and then how do I solve for 2? What's 2y equal to? Not only do these diagonals form a 90-degree angle, but because it's a rhombus, they also bisect one another.
Ooh, okay.
Okay? In other words, that segment's equal to that segment, and this segment's equal to this segment. So what equation can I write? Now remember, we're looking at segments, not angles.
Yeah. So we could do 2y's. Could we set that equal to 45?
No, that's an angle.
Oh, so two I.
Don't get your angles and your line segments mixed up, which you're doing. Always
Okay.
know which one you're dealing with. This 3x plus 18, that's an
Uh-huh.
angle because it's got degrees.
Yeah.
Okay? And we know that's parallel to that, so I could have said that's equal to 5x also
Uh-huh.
because of parallel lines, and those are the alternate interior angles.
Okay.
Either one of them is going to give you x of 9. It was more
Okay.
direct. It was more direct to just say 5x is equal to 45 rather than 5x is equal to that whole thing.
Yeah.
In terms of the line segments, 2y is a line segment. How do I know? There's no degree.
Because well, there's no degree
There's
mark
no
on.
degree. Every angle has a degree thing.
Yeah.
So
Besides that one.
since these two diagonals bisect one another, what is 2y equal to?
2y would be equal to 180.
That's an angle.
So let's see.
What does it mean if I say two lines bisect one another?
Oh, 2y would be equal to 10.
There you go.
There we go. Yeah.
That's
There
what
we go.
bisect means. Bisect means split into two equal parts.
Okay.
That part's equal to that part, and that part's equal to that part.
Okay. Yeah.
Okay? And then that makes y equal to 5.
Okay, cool.
And 29, what kind of a shape is that? Or what kind of a quad is that?
That's a rhombus.
What's the primary definition of rhombus?
Rhombus has two congruent opposite sides.
No, the primary definition of a rhombus is 4 equal sides.
4 equal sides. Okay. 4 equal.
Also happens to be a parallelogram. You can't draw 4 equal sides without drawing a parallelogram.
Uh-huh.
We know that this is not a rhombus
Uh-huh.
because this side is not equal to that side.
Yeah,
So what is it if it's not a rhombus?
Then if it's not a rhombus, would it be a trapezoid? No.
Parallelogram.
Just parallelogram?
Yeah. In other words,
Okay.
it's a parallelogram
Mm-hmm.
that's not 4 equal sides.
Okay, yeah.
What is the property of a parallelogram besides having opposite and equal sides? In other words, this side we do know is equal to that in a parallelogram, and we know that's equal to that. There's one other very important property. What about opposite angles?
Yeah, opposite angles have to be congruent to each other.
Okay, so that's equal to that, and that's equal to that.
Yeah.
Give me an equation that lets me solve for x.
4x plus 7 is equal to 5x minus 6.
Solve that in one step.
Yeah, so it'd be 1x. So yeah, it'd be x is equal to 1. Well, or plus 6, so it'd be x is equal to 13.
That's really funny. My last student said 1 also.
Really? Yeah, I was looking at minus 6. I forgot, like, you have to have the opposites, so.
Let me tell you the way I think about solving equations.
Okay.
This may or may not help, but in algebra class, the way they teach you to do this is this way. Okay?
Okay, yeah.
I'm always going to give you the right answer, because that always gives you 13 and 0 over there.
Uh-huh.
Okay?
Yeah.
But to me, it always seems like a bit of a waste of time to write that.
Okay.
Because it's always going to be 0, right?
Yeah,
So why
exactly.
write anything?
Uh-huh.
So the way I solve algebra problems, if I have a number that's being subtracted and I want to move it to the other side,
I
just change its sign and move it to the other side. So I know that I can get rid of that thing by making it a plus 6. The opposite, whatever its sign is, just change it and move it over there.
Okay, yeah.
That's how you get 13, and you won't make that mistake.
That makes sense, yeah.
It's an easy mistake to make. Like I said, my last student made exactly the same mistake. What
Uh-huh.
equation can you give me to solve for y?
Y plus 3 is equal to 2y plus 1.
Solve that.
Then by is equal to 2.
Good. Good. See, once you get kind of used to solving that in one step instead of two,
Uh-huh.
it becomes actually pretty easy.
It does, yeah.
Yeah.
You're right.
And it saves a step. Saves
Uh-huh.
writing one more step. So, all
Exactly.
right.
Cool.
Let's look at 30. I'm not sure
Okay.
which of these we want to look at and which ones we don't. I still don't have an email from you.
That is weird, yeah. Huh.
And I'm getting emails. I got emails from my last two students today.
Yeah.
So it's on your end. I'm just not sure what's going on.
Me neither, yeah.
All right.
Okay.
Diagonals of a rhombus are 6 inches and 8 inches. Well, let's draw a
Perimeter.
rhombus.
Okay.
What's the main thing I need to know about a rhombus?
That
What's the main
all
four sides?
yeah. All four sides have to be congruent to each other.
And it doesn't have to be a square, but it's either going to be a square or it's going to be a parallelogram like this.
Uh-huh.
Okay,
Yeah.
rhombuses are parallelograms always.
Uh-huh.
So
Yeah.
what they're telling us is that one diagonal is 8, the other diagonal is 6.
Mm-hmm.
Which one is 8?
Doesn't matter like which one's 8.
Well,
It's the larger
which one
side.
is the longest one?
The top and bottom.
The one that goes from lower left to upper right is the longest one, right?
Yeah. Yeah.
So that's got to be 8.
That makes sense.
The other one is the 6.
Is a 6.
And what else do we know about rhombus diagonals? What do they do to one another?
They bisect each other.
Which makes this segment how much?
That makes that segment.
If it's 8
9.
from here to here, how much is it from here to here?
4. Just half of it.
And this segment?
And that would be 3 and 3.
Well, what's that make this side? If that's a 3, 4, we know that's a right angle, right?
Uh-huh.
The diagonals also make right angles with one another in a rhombus.
Uh-huh.
So what is this side?
That would be, would you...
What kind of triangle is a 3, 4?
3, 4,
5.
and 5. Just, okay.
The most, it's the first right triangle. It's called the lowest Pythagorean triangle.
Okay.
Which is a right triangle whose all 3 sides are whole numbers.
Okay.
You can't get one smaller than that.
No.
3, 4, 5. Not only that, but you'll run into 3, 4, 5 triangles for the next 3 years, repeatedly.
Okay.
They may not be 3, 4, 5. They may be 6, 8, 10, or they may be 30, 40, 50. But learn to recognize when you see 3 and 4, if it's a right triangle, the other side's going to be 5.
Okay.
Yeah. Okay, so that's 5. What's the perimeter of my rhombus?
The perimeter would be 22. Oh, the perimeter. My bad. So it'd be 5, 10, 15, 20, yeah.
Okay.
So the perimeter would be 20.
Right.
Cool.
All right. Have you gotten into similarity?
Not yet. No. Not yet.
Well, all right. Let's not do 31 then.
Okay.
Because 31 is talking about similarity.
Oh, okay.
There's nothing special about similarity. The most important thing about similarity is corresponding sides are proportional. In other words, whatever the ratio of AD to FJ,
It's doubled, right?
Same, I don't know, but it's the same ratio as AB to FG.
Okay.
Same ratio to the diagonals. DB is to JG as
Uh-huh.
AB is to FJ. So once you
Okay.
figure out the ratio of proportionality,
Hmm.
then you can figure out every side. In other words,
Okay.
they're telling you that this diagonal is 5,
Uh-huh.
and it's also the ratios within are the same. It's kind of an
Okay.
odd thing. It can't hurt to talk a little bit about it.
No, not at all.
In other words, if I have two rectangles that
Uh-huh.
are similar, if that's x and that's y, and that's 2x and that's 2y, in other words,
Hmm.
the similarity ratio is 2 to 1,
Uh-huh.
then whatever that diagonal is, this is twice it.
Okay. Yeah, that makes sense.
And that's how you do similarity. And it doesn't matter whether you're dealing with quadrilaterals, rhombuses, triangles. In other words, same thing with a triangle. Let me draw two similar triangles. This is probably the next thing you'll get. If I draw that same 3, 4, 5 triangle, and over
Uh-huh.
here I draw a 6, 8, 10 triangle. They're both right triangles. What's the similarity ratio?
1 to 2.
Correct. Okay.
Yeah.
So if you didn't know that this was 4, but you knew the triangles are similar,
Yeah.
you'd know that was 4. Just
Uh-huh.
based on the fact that everything is twice as big over here as it is here. Well,
Okay.
it's not just 10. In other words, I can say 10 is to 5, as 8 is to 4, as 6 is to 3. In
Uh-huh.
other words, corresponding parts between the triangles. But what's actually more interesting is that the ratios within are the same. In other words, I can
Okay.
say the ratio of 5 to 4 has to be the same as the ratio of 10 to 8.
Uh-huh.
Notice they are. They're both 5 to 4.
Uh-huh.
And has to be, if I said the ratio of 4 to 3 within this triangle alone, that's the same
Yeah.
as the ratio of 8 to 6. So it's not just the ratios between the triangles, it's the ratios within the triangles are the same also.
Okay.
And it doesn't matter if it's triangles, it's all polygons.
Okay. Cool.
So that's the thing about similarity.
Okay.
But let's not do that problem. I don't want to spend time on what won't be on your test tomorrow.
No, no problem. Yeah.
But similarity is not that hard. Congruency is actually much harder than similarity. To prove similarity, you just need 4 equal angles or 3 equal angles. That's what
Okay.
proves similarity. Well, it doesn't for quadrilaterals. It does for triangles. For a triangle, the only thing you need to prove similarity is angle, angle, angle.
Mm-hmm.
Okay?
Yeah.
For a
Okay.
square, that's not true because a square is not similar to a rectangle, but a square has all 90-degree angles, so does a rectangle. So that definition of similarity changes when you get above triangles.
Mm-hmm. Okay. Yeah.
It's kind of an interesting problem.
Okay.
Only because you'll see as we go through it.
Okay.
They don't really give you enough information to answer 36. You'll see why.
Okay. Yeah, it doesn't. No.
No. Well,
No.
it's not totally clear why it doesn't, but
Okay.
we'll see once we go through it. What is the measurement of DAC?
The measurement of DAC would be um given that, so find the indicator measure. So would you do just 180 minus 53 to find one of those angles?
No. Fact is, they don't give us the information to solve for that either.
No.
How did I not see this the first time I looked at this problem? The diagonals of the rhombus intersect at E. Given that BAC is that 53-degree angle, BE, well, let's draw as much of this rhombus as we can and label.
Okay.
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 I'm assuming that that diagonal is 8.
Yeah, me too.
That's what they mean, okay?
Okay.
That's 53. Well, if that's 53, what's this angle down here?
53 as well, because they're alternate.
Because it's a parallelogram also.
Yep.
The diagonals also bisect the angle. So this angle has to be 53.
Okay.
That's by definition. That's how we knew how to figure out that angle.
Okay.
Okay.
Yeah.
Now, what is angle AED?
So angle AED would be, well, you do 180 minus 53.
Oh, there's something about rhombuses and diagonals. You got to memorize it. In other words, these properties, unless there's only one way to figure it out, and that's to memorize it. It's not something you can figure out unless you have memorized.
Okay.
The diagonals of a rhombus do what when they meet at the intersection?
When they meet at the intersection, well, they bisect.
Do two things. They bisect each other. What else do they do?
They intersect each other, so they're perpendicular.
Not because they intersect one another. They're perpendicular because it's a rhombus. Only rhombuses do that.
90 degrees.
In other words, if I took a parallelogram that's not a rhombus, like this,
yeah,
I draw the diagonals, they do not intersect at a right angle.
Okay, yeah.
Same thing with a rectangle. It's only squares and rhombuses whose diagonals intersect at right angles.
Okay.
So that's what allows me to know that's a right angle.
Okay.
Now, if that's a right angle, and that's 53 degrees, what's this angle right here?
So it'd be 90 plus 53.
90 minus 53.
Or 90 minus, my bad. That'd be 37.
Okay. So, what's angle ADC?
ADC would be also 37.
ADC is the big angle.
Oh, I was looking at that one, my bad. So...
What do we know about diagonals? They bisect these angles, so what does this angle have to be?
37.
What's the sum of those two?
E3. So that'd be 90, yeah.
Add the
down.
right there.
Okay.
You're right that 37 plus 53 is 90. That's a right triangle. So the two acute angles are always complementary.
Yeah.
But what is this angle? ADC is the sum of these two angles.
74.
Okay.
Yeah.
And side DB. This 8 must refer to DE.
Yeah.
In other words, that's 8. What is DB?
So DB would be 16.
Correct. Now, AE.
Okay.
That's this side right here. They do not, actually, they have not taught you enough math to figure out how to solve for that.
No.
They just haven't. That's a trig question.
Oh, okay.
The thing is that I happen to recognize there's not too many people that would know what the angles of a 3, 4, 5 triangle are.
Okay.
That is the lowest Pythagorean triangle.
Okay.
What they never tell you is, what are those angles? Well, guess what? That's 37, that's 53.
Okay. Yeah.
So, what we're looking at here is a perfect Pythagorean 3, 4, 5 triangle. Only it's not 3, 4, 5. This side is 8.
Mm-hmm.
So what is the dimension of AE? If that is a 3, 4, 5 right triangle.
So if it's a 3, 4, 5 right triangle, wouldn't you just cut that in half or no?
Well, no. In other words,
Well,
that's half of 4,
yeah.
but this is the other side. So this
So
would
it would
be 6.
6. Okay.
In
Oh, and then that'd be 10, and then that'd be 8. Okay.
other words, that's a 3, 4, 5 triangle times 2.
Okay.
Okay.
Yeah, that makes sense.
The only way to really solve that, they don't give you enough information to solve this for 6 without some trig, without invoking trig, or unless you happen to know what these two angles are. There's not very many people. It's almost it's only because I'm a math tutor and I'm always running into 3, 4, 5 triangles that I have to remember that those angles are 37 and 53.
Okay.
I saw this 53-degree angle there. I know that's a right angle. That has to be 37. That's a 3, 4, 5 triangle. And if that's 8, then that has to be 6.
Okay.
But at this point in geometry, they really did not give you enough information to solve for AE.
No, they didn't.
No, they didn't. There's no way.
Yeah. No.
It's a trig function. It's actually the inverse tangent of 53 degrees is equal to 8 divided by 6, or x. So if you had trig knowledge, you'd be able to solve it. But just geometry, you can't really solve it. What's the length of AC? If 8 6, what's AC?
AC would be 12 then.
Okay.
Yeah. Cool.
Okay, here we have diagonals of a rectangle.
Mm-hmm.
And notice that rectangles, the diagonals do not intersect at right angles.
No.
They do bisect one another. But that's not a right angle. That's 34 degrees. What else do they tell us? QS is 10.
Yeah. So QS would be 10.
That whole line is 10.
Okay.
That's all they tell us. So, what is the measurement of SRT, this angle right here? We'll call that X.
Okay, so the measurement...
This is a rectangle, so that's a right angle there.
Yeah, so that'd be 90 minus 34.
Good. What is that?
66.
56.
56, yeah.
Always remember the first two numbers have to add to 8, unless you have a 0. If you have anything but a 0, in other words, if I want to know what's complementary to 31, I know it's got to start with a 5, because it's got to be 5 and 3 have to add to 8. The other number obviously must be 9.
Yeah.
Have to add 10. Okay? Same thing if you're looking for supplementary. In other words, if you're subtracting an oddball angle like 92 from 180, I know that the first number, these have to add to 17. 8 plus 9, those have to add to 17. This has to always add with 2 to come up to 10. That's the way you do it when you're subtracting from 180.
Okay.
Just make your first number add to 17. Well, when you're subtracting from 90, make your first number add to 8.
Okay. Makes sense.
Yeah,
Okay.
a little bit more way of being accurate, because you'd be amazed at how many people make that mistake right there.
Uh-huh.
Because all they do is they're putting 3 and 6 together to come up with 9.
Uh-huh. Yeah.
But you have to add the other 2 digits too, which are always going to add to 10. So these first 2, that's why they always have to add to 8.
Okay.
Okay. That was QPR. No, that's a different one. That was
Yeah, that was SRT.
RT. So now they want this angle right there.
That would be 90 degrees, wouldn't it?
No, remember the diagonals of a rectangle do not make a right angle where they cross.
Oh, that's right. Yeah.
Only if all 4 sides are equal that they make a right angle.
Okay.
Okay?
Okay.
So, let's see. What's this angle right here?
That would be 34.
Okay?
Okay.
What's this angle right there?
56.
Okay? Ooh. No, it isn't.
It's not.
No. What is it is the question.
Yeah.
Let me think for a moment here.
Okay.
We know this is 5,
Uh-huh.
half of 10,
Uh-huh.
and that this angle that they're asking about is the same as this angle down there, but we don't know that angle either.
No. They don't give you enough information.
Well, you're just about right, because notice how I can prove that.
Uh-huh.
If I make a longer rectangle, I'm going to change that angle that they're talking about. That angle there is not the same as this angle up here. Okay, the longer I make my rectangle, the smaller that angle becomes.
Okay.
Okay, so the only information they gave us was the length of the diagonal.
Yeah.
Not so.
Okay.
I do know something about this triangle here.
Okay.
It's similar. I mean, it's congruent. Remember yesterday when I drew a rectangle, drew a diagonal, and said, prove these 2 triangles are congruent?
Yeah.
We were able to figure out all 4 sides and all angles.
Okay.
Okay? So here's what I'm saying. This triangle right here is congruent to this triangle right there.
Okay.
So what does that make this angle up here?
So that would make that angle
If there's
56.
Right, 56.
Yeah.
That's the corresponding angle as this 56-degree angle.
That makes sense,
Makes
yeah.
this 34. Now we know what this angle is.
Which would be 34.
Right.
Yeah.
Okay. And let's see. It makes angle X what? If that's 34 and that's 34.
That would make X.
So those two total is 68. Now subtract that from 180. What's the first number got to be?
That would be 222.
No. What adds to 6 to make 17?
Just 1.
11.
11. Oh, yeah, my bad.
Okay. 11 plus 6 is 17, and that's what you need to add them up to, is 17.
Okay.
O is going to be 2.
Uh-huh.
So that's what that angle is, 112 degrees.
Okay.
In other words, the three angles have to total 180.
Okay. Yeah.
Right?
Okay.
And now side QP, they've told us that QS is equal to 10. What is QP equal to?
So QP would be equal to 5.
Because the diagonals do bisect one another on rectangles and rhombuses.
Uh-huh.
Okay?
Yeah. Cool.
RP.
RP would be the same thing.
Correct.
Would be
Also
5. Uh-huh.
QR.
QR would be... That'd be 10, wouldn't it?
No, that's the one they don't give you enough information to really solve for.
Yeah.
I mean, they do, but it's a trig question again. Interesting.
Is it?
Yeah, in other words, QR is the same as TS, right?
Yeah.
Okay, so let's draw a triangle.
Okay.
And the only information they've given us about this triangle is that's a 34-degree angle, that's a 56-degree angle, and that distance is 10.
Yeah.
Well, this is very similar to the previous question. That's real close to a 3, 4, 5 triangle.
Yeah.
In other words, the previous question, these angles were 53 and 37. Well, that's not that close, 34 and 56. I know that's a right angle, but to come up with this side, which is what they're asking for, or the bottom side, we'll call that X and call that Y. You need trig. You can't do that with geometry.
You can't, no.
No, here's why. In other words, I can say that the sine of 34 degrees equals the opposite over the hypotenuse. So I can solve for y, but I got to know what the sine of 34 degrees is, and the only way I can get that is off of a calculator or off of a table or something.
Yeah.
We don't know what the trig function is.
No.
We have to have the only way to solve for either the height or the width of this rectangle is using trig.
Okay.
In other words, y would be 10 times the sine of 34 degrees. Now, it's not like you don't know how to do that. You know how to go into your calculator and get the sine of 34 degrees, right?
Yeah.
Multiply it by 10 and you have that side.
Yeah, exactly.
Okay?
Yeah.
Cosine of 34 degrees would equal x over 10. So x would be 10 times the cosine of 34 degrees.
That makes sense.
You can solve for x and y, but it requires trig, and it's puzzling. You haven't really had enough trig to do that at this point in geometry. You've had a little bit of trig, but probably not enough to be able to solve for that.
Yeah.
And solving for QR and RS is basically the same thing. One is the base of this triangle, the other is the height.
Yeah.
Both of them require these two formulas down here.
Okay.
Okay.
Cool.
So we won't worry about that.
Okay.
Squares. Is that background from your end or mine? I don't think there's anybody else in my house, but
probably my sister.
Yeah, so I'm assuming it's on your end.
Yep. I hope so.
If it was on my end, my dog would be barking.
Yeah.
Big time. So.
Oh yeah, for sure.
Right.
That would be good.
All right, so let's look at these questions about the square.
Okay.
These are actually fairly easy, I think. And I believe we have all the information without trig to do this. So all we need is triangles. What do we know the diagonals of a square do?
They bisect each other.
Plus?
Make 90-degree sides.
They form 90 degrees.
Or they form.
At the intersection.
Yeah.
And if it forms one 90-degree angle, it forms four 90-degree angles. Always.
Because they're all the same to that, yeah.
Okay, and they tell us that this side is 1. From L to the middle, K.
Okay.
Okay? What's the measurement of M, K, N? M, K, N.
Well, so 91. So we know that there's a 90-degree angle within that.
What's the measurement of angle MKN? What's this angle right here?
That 90 degrees.
Okay. What's the measurement of LMK? This angle right there.
That would be 90. No. That'd be 45.
Right, because that's what else diagonals on squares do.
Yeah.
They bisect the angle. Same with diagonals on parallelograms.
What are diagonals on parallelogram?
Yeah, they bisect. Even if I draw a long parallelogram like that, yes, they do bisect one
another. They do, yeah.
That's equal to that. And that's equal to that.
Okay.
Okay? So squares, parallelograms, rhombuses, they bisect one another. They don't on a rectangle. A rectangle's diagonal does not bisect. That's a much smaller angle than that is. Okay? But with squares, they do. So that means that's 45 degrees.
Okay.
That was LMK. How about LPK?
LPK would be 45 degrees also.
Okay. The measurement of KN.
KN would be 1.
The measurement of MP.
MP would be 2. My bad.
2? Okay. And the measurement of LP.
Let's see.
It's a little harder. What I'm going to do, here's LP.
Okay.
Take that triangle. I'm going to draw it like this. We know it's a right triangle because this is a right angle right there.
Yeah.
What they're telling us is that's 1. We know that's 1. So what's that measurement if it's a right triangle and both sides are 1? How do I get the hypotenuse? In other words, LP is the hypotenuse of that right triangle.
Yeah. So if those two are 1, that one would have to be 2 because...
When you're solving a right triangle, always begin your answer with square root of.
Square root. Oh, okay.
It's the square root of 2.
So that'd be 1.
Remember, we got 6 minutes. I can't think of a better way to spend them than solving right triangles. Okay? So I'm going to give you some right triangles. To solve. Okay? First of all, know that whatever that is, this is the equation that governs them. A squared plus B squared equals C squared. Okay? So, if I'm solving for C, which I was in the last problem, C is equal to I take the square root of both sides and I get this.
A squared plus B squared, yeah.
The square root of A squared plus B squared. Okay? So in our problem, it was the square root of 1 squared plus 1 squared. That's the square root of 2. Okay? So if you're solving for the hypotenuse, the answer always begins square root up. Now, it might end up being square root of 25, which would turn into a 5, but you still start out, as long as you remember to always start your answer out square root of, you won't make the mistake you made.
Okay. Yeah.
Now, let's say that I'm solving for one of the sides. Let's say I'm solving for A. Well, A is going to be the square root of C squared minus B squared, right?
Yeah.
If I was solving for B,
it would be
square root of C squared minus A squared.
Yep.
And if I'm solving for C, it's just the square root of A squared plus B squared.
Okay.
Every one of these starts out with square root of. Only the hypotenuse has plus going on inside the radical, but every other one has squares going on inside the radical.
Okay. Yeah.
So you have to take the square root of, and then everything inside has to be squared. If you're solving for a single side, then you're subtracting the hypotenuse squared minus the other side squared in both this and this. So you don't really need both of those. You don't need to write both of those when you're memorizing it.
No.
You just need to know that if you're solving for one of the short sides, it's the square root of the hypotenuse squared minus the other side squared.
Okay. Yeah.
So let me give you some numbers here.
Sure.
Tell me what A is.
So A would be equal to 5 squared minus.
Always start your answer with what words?
Square root.
Square root of.
Yeah, square root of 5 squared minus 7 squared.
What's the hypotenuse? C is the hypotenuse.
My bad. Yeah, 7 squared minus 5 squared.
Okay.
Yeah. My fault.
What's the hypotenuse?
6, or C would be equal to 6 squared minus 5 squared.
Hold on. Always start your answer with, the only mistake you're making
my bad,
is you're leaving out square root of.
Yeah, my bad.
So it doesn't matter which side you're solving in a right triangle. All of them begin square root of.
Okay.
Square root of what?
So it would be the square root of A squared minus 5 squared.
No.
6 squared minus 5 squared.
Plus A squared plus B squared.
So it would be 6 squared plus 5 squared.
There you go. It's only when you're solving for one of the short sides that it's inside. Okay? If I say that's 40 and that's 11, what's X?
And then X would be, X would equal the square root of 11 squared.
No, the hypotenuse always goes first. Remember, the hypotenuse is the longest side of the right triangle. If I did not put it first, I'm going to end up with a negative number.
Okay.
Let's just say I made the mistake and I did this. Well, notice that 40 squared is a lot bigger than 11 squared.
For sure, yeah.
You have the square root of a negative number. If you find yourself taking the square root of a negative number, you've got your numbers backwards.
Okay.
You're never going to find the square root of a negative number when solving a right triangle.
Okay.
Okay? I'm going to keep giving these to you because there's nothing that's better for you to be better at than this.
Okay.
What's X equal to?
X would be equal to the square root of 3 squared, or 4 squared plus 3 squared.
Simplify?
X would be equal to the square root of 9 plus 16.
Simplify?
And then X would be equal to 3 plus 4.
Hold on. No, add those two numbers. Don't add the square roots of those two numbers.
Oh, my bad. Yeah. 25. So X would be equal to 25.
No. X is the square root of 25. What's the square root of 25?
X would be equal to 5.
Ah, that's a 3, 4, 5 triangle.
There we go. Cool.
Okay.
Okay.
All right.
Cool.
It's a good stopping spot.
Okay. Yeah, that was real helpful too.
Good. Good.
Yeah.
No, I think this definitely we're making some progress.
We are, for sure.
I will talk to you again tomorrow at 5.
All right, sounds good.
Yeah,
Thank you.
I still do have a couple more pages from this previous student. I don't.
Sweet.
Yeah, we didn't look at. I think I have 2 more. Let's see. Is this one? Yeah. No, we didn't do this one, and we didn't do this one here. So
Sweet.
we might have enough material. Yeah, this involved diamonds or kites. Have you gotten
okay.
Have you gotten to kites and trapezoids? I noticed.
We have. Yeah, we've gotten to that.
Okay, cool. This
Awesome.
material will be perfect for tomorrow night.
Sounds good. All right.
All right, Dylan.
All right. Well, thank you. I appreciate that.
You're welcome. Talk to you then.
All right. Sounds good. Bye-bye.